So just to give you a little more concrete challenge, I want you to find for me which quaternion corresponds to a 270-degree turn around the z-axis, okay? So 3/4 of a turn around the z-axis, let's say in the counterclockwise direction as you face it from above. All right, so the way you do this is first set the axis to be fully in the z direction. So the k value is 1, but the I and j values are 0. And as we alter our angle here, bringing it up to 45 degrees gives us a quarter turn. Changing the angle up to 90 degrees gives us a half turn. So it's when you change it all the way up to 135 degrees that we have 3/4 of a turn. So rotating the sphere 270 degrees involves changing this angle to be half that, 135. And if we change out of the angle axis representation, we can see this simply as a quaternion with 4 components. And you'll notice that it has equal parts real and k. But I want you to notice one more thing here. There's 2 ways we could think about orienting the sphere like this. What I just did, we rotated it 3/4 of a turn counterclockwise, right? But you could also just rotate it negative 90 degrees, which involved changing that angle to negative 45. And when you do that, and you look at what quaternion's being represented, again, it's equal parts real and k, but it's actually the negative of what we had before. Before, the real part was negative and the k part was positive, but here the real part is positive and the k part is negative. So we have 2 separate quaternions corresponding to the same orientation in 3D space. The phrase you'll sometimes hear referring to this phenomenon is that quaternions are a double cover for rotations in 3D space, which basically means any given orientation corresponds to 2 separate points on the opposite side of a hypersphere in 4 dimensions that we cannot see. And the reason this happens is because of the angle doubling phenomenon, right? I mean, think about it. As we change this angle up to 180 degrees, the orientation it corresponds to rotates 360 degrees, getting back to where it started. However, the quaternion it's representing has rotated 180 degrees around the hypersphere. In this case, it went from being 1 to being negative 1. So go ahead and keep playing around a bit if you'd like to build that intuition for which quaternions correspond to which rotations. And in the separate sections, I'll explain why this happens in the broader 4-dimensional context of what quaternion multiplication does to a hypersphere.